In this lesson, you will learn how to calculate correlation coefficients and construct scatter plots between two continuous variables in Stata. Hi, I'm Professor KK, your own Stata professor. Do you want to learn Stata but do not know where to start? Are you afraid of its commands? Do you think that it is too difficult? Then you are watching the right video series. I am going to teach you Stata easily, quickly, and without tears using its extensive menu system. This is Introduction to Stata using menus in 28 lessons. We will continue working with the same dataset and do file as before. You can find links to download both in the description of this video so that you can follow along. After opening the do file, we open the data file. We have learned this in earlier lessons. To get a preliminary understanding of how the different continuous variables in our dataset relate to each other, we first look at their correlation and then we look at their scatter plot against each other. We will calculate the correlation coefficients using the pwcorr command. This particular dialog box is located deep inside the statistics menu. We first go to the statistics menu, then to summaries, tables and tests, and then to summary and descriptive statistics, and finally to pairwise correlations. This activates the pwcorr dialog. In the dialog box, we have to select at least two continuous variables. Therefore, we select pulses 30 and serial 30. And then we click on submit. The command that Stata executes is pwcorr space serial underscore 30 space pulses underscore 30. The correlation coefficient between these two variables is approximately 0.3. If we want to calculate the correlation coefficient between more than two variables, then we have to select more than two variables in the variables field. For example, we can select another variable, let's say fruits 30, and then press submit. And Stata will show the pairwise correlation between serial 30 and pulses 30, serial 30 and fruits 30, fruits 30 and pulses 30. So all the three pairwise correlation coefficients will be calculated by Stata. Along with the correlation coefficients, we might want to know how many observations are being used to calculate each of these correlation coefficients. Therefore, in that case, we have to select print number of observations for each entry. If we select this option and press submit, then Stata just below the corresponding correlation coefficient shows how many observations have been used to calculate each of these correlation coefficients. If there is a variable which has some missing values, in that case, the number of observations used for calculating a correlation coefficient involving that variable will be smaller than the number of observations for the entire dataset. In our dataset, that is not the case. None of these three variables have any missing value. Therefore, all the 71,174 observations of the dataset are being used to calculate each of these three correlation coefficients. Let's now create a scatter plot between the variables serial 30 and pulses 30. Scatterplot requires two variables. One variable goes to the y-axis and the other variable goes to the x-axis. Since it requires two variables, Stata classifies scatterplots as a two-way graph. A two-way graph dialog box is located in the graphics menu. So we go to the graphics menu first, then activate the two-way graph dialog box. Within the dialog box, there are lots of options and bells and whistles available. We will stick to the basics. First, we have to define a plot. Therefore, we click on the Create button. And that brings up the plot 1 dialog box. Within the plot 1 dialog box, we select the basic plots option, and then within basic plots, we select scatter as our graph type. Then we have to select a y variable. Therefore, we select pulses 30 as our y variable, and we select serial 30 as our x variable. Other than that, we do not change anything. Although keep in mind that using the marker properties, using the marker weights and color variable, we can change the look and feel of the graph to a large extent. Let's now press accept. Earlier, the plot definition field was empty. Once we have defined our first plot, it shows plot 1. If we select plot 1, then just below this field, Stata shows us what will be the command that will be used to create this plot. And the command is scatter space pulses 30 serial 30. Note that we can create multiple plots and plot them together in this graph. For the time being, we are plotting just one scatter plot. Now we press the submit button and Stata shows us the graph in the graph window. The result window says that the command that Stata has used is twoway, then within parentheses the same command that Stata shows in the dialog box. The parentheses are there because we could have defined multiple graphs and plotted them together. We will learn that in a later lesson. Each blue dot in this diagram represents at least one observation. If multiple observation has the same x and y value, in that case, the same dot will represent multiple observations. The x-axis says 129 cons value and the y-axis says 159 cons value. These do not say serial 30 and pulses 30. That is because 129 cons value and 159 cons value are the variable labels for these two variables. And Stata by default uses the variable labels to name the two axes. Now, if we look at the graph, we see that there is a slight bit positive relationship between these two variables. That is, households which consume more of cereals, which is plotted on the horizontal axis, seems to consume more of pulses as well, which is plotted on the vertical axis. And this positive relationship was indicated by the positive correlation coefficient between these two variables, which was 0.3 approximately, or in very precise terms, it would be 0.2947. Although the relationships are positive, it is not that strong. We can change the look of this graph by choosing the many options allowed by Stata in the two-way dialog box. We will learn some of this in a later video. For now, feel free to explore the two-way dialog box on your own. We now copy the three correlation commands and also the two-way scatterplot command from the history pane into our do file for saving them. Then we save the do file. There you have it. In just a few minutes, you have learned how to calculate pairwise correlation coefficient between pairs of variables, and also how to visually inspect your dataset by using scatterplots. In the next lesson, we will learn how to bring a categorical variable in the scatterplot as a third dimension. So stay tuned. If you like these videos but have not yet subscribed to my channel, please consider subscribing, hit the like button and the notification icon so that you do not miss any of these videos. And also consider sharing these videos within your network so that others can learn as well. And as always, keep learning. Thank you for watching.